Dear students, welcome to Sia's digital classes. Today's concept is median. Let us discuss about median today. So median is nothing but the middle value of the given observations. It divides the distribution into two equal parts because it becomes a mid value, right? So the data will be divided into two equal halves. So this side half you'll get, the other side half the data you'll get. So half of the observations in the given set are lower than it and half of the observations are greater than it. Why? Because we'll be arranging the data in ascending order. So like that you'll get first half will be lower and second half will be the greater values. So it is also called as a positional average because it decides the position of the data. So positional average also will call. So next median is also called as it is divided into two equal groups. So it divides the data into two equal parts. So one part compromising all the values greater and the other all the less than values. We'll arrange the data in ascending or descending order. So the greater values, lesser values will be divided. Upside greater if you get, downside lesser you'll get. If ascending order, if you'll arrange lesser values first you'll get, then the greater values you'll be getting. So that is how medians. Actually we'll go for median so that whenever data is nearby data you have, so instead of going to mean, you can directly go to the median, getting the value directly. It's an average itself, so directly take the middle value, that becomes a average which represents the entire data, means how the average is going on for the entire data it represents. So when we'll go for mean, what we'll do, we'll take the average of the entire data, then we'll give that answer as a representation for the entire data, right? But here median, directly if you go for the middle value, that becomes your average. So median is also an average, easiest one. Directly we can go for the mid value over there. So let us check it out, the steps for individual data. So merits and limitations is also there. Let us check it out that, then we'll go for the problem or the individual data, how it goes on. Next we'll check it out. First let us check it out, the merits and limitations. Merits as nothing but uses of the median, where it is used, how it is used, like that. So it is firmly defined. Firmly defined is nothing but properly formula has been defined and it's very easy to calculate. Yes, it's very easy, directly mid value, and for continuous data also small formula will be having in the, with that easily we can find out the median. So next, it is not affected by extreme observations. Yes, extreme observations will not impact because first beginning of the values or the ending of the values will not take in median, right? Exactly, middle value will consider. So for that, if at all extreme values are there, like big values are there or a lot of values are there, still will not show impact on the data because we'll consider the mid value over there. Next, it can be calculated for open-end classes also. Yes, open-end classes in first unit we'll discuss different varieties of classes, right? Open-end classes in the sense from beginning open data will be like below, above, like that they'll specify. Directly 0 to 10 like that they'll not specify. Those are the open-end classes. Open intervals, class intervals they'll give 0 to 10, 10 to 20, not like that. Starting lower limit they'll not specify, ending upper limit they'll not specify. Such a type of data will call as open-end data. Yes, it is not impacted here. Why? Because mid value will consider. We have nothing to do with the first limits and the last limit. So open-end classes also happily we can go for the median. Next point, it is the only average which can be calculated for qualitative characteristics based on their magnitude. Yes, qualitative type of data also will deal in statistics. That also we have learned in first unit, how the qualitative type of data will be and how to calculate it. So median is the best one. Whenever qualitative type of data is there, we can approach through median. Next is the limitations we have, where data is not proper or where the median has got certain limitations that we cannot follow for the particular data. Those are some limitations we have. That is, it cannot be calculated accurately for the even number of observations for ungrouped data. In the sense, whenever even observations are there, anyhow we'll be dealing that in example problem. At that time will be understood very clearly. So even data, odd data will be there. So whenever even type of data is there, exactly median will not get. We have to go for average again. So that's what they are specifying here. Even data you will not get median properly. Next, it is not suitable for further mathematical treatment. Yes, further we cannot utilize that one. Further, no more formulas will be there. Directly you'll get the median. Then and there we'll stop it. Next, it is less stable than mean. Yes, it is not so accurate as mean, because mean for each and every value will consider, for entire observations will consider, and will take the average over there. Yes, mean is the best average, we can say. For that, median as doesn't got that much importance, because median is just a mid value. But based on the data will be going on, right? Like some data is a median is the best one, we'll go for that. For some data, just we have to stick with mean. So one of some limitations is that mean is the best, then comes the median. So that's what is your third limitation we have. Now let us calculate median for individual series. Yes, we have three types of series already we have discussed for mean, right? So individual, discrete and continuous, three types of series or three different types of data we'll be having. Based on the data, we'll go for the particular formulas, isn't it? So let us go for individual series, how to calculate median for individual series. So we have some steps over there, check it out. Arrange the data in ascending or descending order. Yes, definitely whenever you want to find out median, you have to arrange the data in ascending or descending order. Individual, you know, right? Single row or single column information will be having, or single column or single row data will be having. For that, we'll arrange that data in ascending or descending order first. Then what we'll do, if the number of observations are odd, then median is the middle value of the arranged data. So if the number of observations means count the data, if it is odd number, so directly exactly middle value will get for that. That becomes a median. So happily that whatever the mid value will get, that becomes a median. But if it is even data, at that point of time, what you have to do is you have to take arithmetic mean wherever exactly mid value will get. Mid value will not get for even, two values will get the type. So that two values again you have to go for the average. In the sense mean you have to do, then that becomes a median over there. So these are the steps. Let us check it out, that particular steps for the problem, and we'll find out the individual data median. So check it out, one of the example, calculate median for the following observations. Now some data, single data they have given, single row we have. So we have to decide that it is an individual series. Now individual series, just now we have checked those steps, right? Let us deal median for that. So arrange them in ascending or descending order. Here I have arranged in ascending order. We know that ascending order is nothing but smaller value to bigger value, right? Less value should come first, then the other next highest, next highest, like that up to the last value. So first value in this least value is 4. So I wrote 4 here. Then comes the 6. Next least is 6. Like that you have to go on arranging. That becomes the ascending order. So ascending order, I have arranged the data. Then go for the formula, or directly check it out middle value, because it's an odd data. Exactly you will get the middle value. This side you leave 3 observations, that side you leave, middle value becomes a median. That's how we can decide. Or if you want to go through with the formula also we have, that is n plus 1 by 2th term. So what is n here? N is a number of data or number of items. Count the number of values here. So never get confused with the capital N. Capital N for individual data is a number of observations. You have to count how many are there, how many observations are there. Like for this data, 1, 2, 3, 4, 5, 6, 7. 7 observations I have. So capital N becomes a 7. And for discrete and continuous data, capital N is different, right? For discrete and continuous, capital N is total number of observations. So whenever we'll deal that particular data, again I'll remind you here, for discrete, for individual series, always capital N is number of observations. Counting the number of observations becomes your capital N. So capital N, I have got counted how many we have. 7 observations we have. 7 plus 1 by 2. So 8 by 2, nothing but 4th term. 4 is not the median. 4th term you have to consider. 4th term in the given data, where after arranging in ascending order. So check it out. 4th term in our data is 1, 2, 3, 4. 4th term becomes 18. So directly you can identify, or through formula, one and the same, mid value becomes the median or the data. So directly you'll get the mid value. 18 becomes the median for us. So that is how we'll find out the median for the odd data. Now let us check it out for even data. So here an example for even data, calculate the median of 6 observations. 6 observations. 6 means even data. So we cannot decide exactly middle value here. So we have to take average of the middle two values. First here also arrange the data in ascending order as usual. So arrange it. Least value comes first, 6, 6 to 12, then 18, then 30, then 40, then 80. So in that way, arrange it in ascending order. Now middle two terms you have to take the average. Middle, exactly middle you are not getting, right? 18 or 30 becomes a middle. So I can't take 18 or 30 directly. I have to take the average again. So what I have done, 18 plus 30 by 2 you do, then you'll get the answer as 24. 24 becomes a median. So for even data, you have to take the average. For odd data, directly you'll get the middle value. So that is how we'll identify median for the individual data. Now let us check it out for discrete data, how median need to be done. So steps we have. First let us check it out the steps. Arrange the variables in ascending or descending. Yes, as usual, arrange the data in ascending or descending order, just how we'll do for an individual case. The same way you have to arrange it. Then find out the cumulative frequencies. Yes, cumulative frequencies we know how to do. In first unit itself we have learned. So arrange it in arrange in proper way. So cumulatives you have to obtain. That we'll check it out in example anyhow. Next formula to get median is size of n plus 2th term. So that we'll check it out how it will goes on. From the cumulative frequencies we'll identify the median. So now these all steps, let us check it out using a example. So here is an example. From the following data, find the value of median. Now check it out the data, how it is. X values and F values they have given. Whenever X and F, in the sense frequency values and some X values related to the frequencies are given, that becomes a discrete data for us. So in this way you need to identify that it's a discrete case. So now let us check it out how the median goes on for the discrete type of data. So first of all, cumulative frequencies you have to obtain. Just now we have learned how the cumulatives will go on. So once again let me remind it how the cumulatives will go on. So just to copy the question as it is, whatever you have. Now take first value of the frequencies and carry on here in the cumulative frequencies. First value carry as it is, write on 24 as it is. Now 24 plus 26, 24 from cumulative frequencies plus 26 from frequency. Next value of frequency. First value of cumulatives and the next value of frequency. If add up, you will get the second value of cumulative frequency. So in that way, add up one value to another cumulatives to the next of frequency, add it, you will get all the cumulative frequencies. Now last value of the cumulative frequency becomes a total of frequency. Check it out, 122, 122, same value you got, right? So total of frequency is nothing but last value of the cumulative frequency. Now take that one. Now what is the formula? Just now we discussed, that is n plus 1 by 2th term, right? N is total of frequency. Take that one, 122 plus 1 by 2 you do, you'll get as 61.5, 61.5th term. So this value you have to check it out in cumulative frequency. If it is exactly is there, go for it. If you don't have exact value in the cumulative frequencies, then check it out next highest to that. So next highest what you have, 61.5 we don't have in cumulatives. Check it out, right? So 50 you have, 70 you would have, you don't have 61.5. So what I said, go for next highest. Next highest is 70. So 70 becomes your median class, but 70 is not the median. Again from the 70, check it out, it's a X value. What you have, X value is 68. 68 is median, not the 70. 70 decides the median class and its corresponding X value becomes a median, not a frequency, not a cumulative frequency. Median becomes a X value, whatever the first value. Like you have your name and your roll number and your marks, like that. If you've got some marks, 50 marks you got, means, so what I'll tell your name and I'll tell you got 50 marks, isn't it? Not your roll number, not just the marks. Marks has assigned for that particular person. So that particular person has got that mark. So that particular person belongs to that particular thing. So here median becomes a 68, not frequency, not cumulative frequency. So 68 becomes a median. So that's how we'll do for the discrete data median. Okay. Thank you.